Hi, my name is Yixuan. Here's my final year project presentation with the title Intelligent Digital Media Analysis of Scam Prevention Measures, which are supervised by Dr. JC. Online scam has been a persisting growing issue. In 2024, there were over 95,000 victims of online scams, leading to losses around 3.18 billion ringgit Malaysia. Breaking this down, we had around 14 phone scam cases and around 7,000 e-commerce scam cases reported. Imagine you are a government agency who regularly sharing scam prevention message across social media and online platforms. So here's the problem. The government agencies lack of effective tools to evaluate the impact of their scam prevention message. There is no system in place for classifying scam and framing strategy used in their scam prevention posts. Besides, the government agencies are unable to optimize their posts due to the limited insights they have into the outreach of the posts. Lastly, the government agencies struggle to determine whether their posts are perceived positively or negatively by the audience. And Scam Insight is your solution. Scam Insight is a web-based system to monitor scam-related posts, analyze public engagement, classify scam type and framing strategies used, and get valuable insights to enhance scam awareness posts. It covers post collection, where all scam prevention posts from government agencies are gathered from their official website, Twitter, and Facebook account. Government agencies can manage the collected posts by creating new posts, updating existing posts, or deleting the posts. The public can engage with the posts by liking the posts, sharing them to their social media accounts, and leaving comments. And the government agencies can view key insights and analytics through the interactive dashboard. So now let's take a closer look into the system. After launching the system, the onboarding screen is shown. There are two types of user account, the government agency account and the normal user account. New user can register by filling in for their username, password, and then confirm the password. And now I will be demonstrate signing in using a predefined government agency account. Once signed in, we will be redirected to the home page. In the home page, on the top left, there is a brief description of the system and its purpose. On the top right, we display the total number of scam-related posts collected so far. Next to it is a summary of scam framing classification. Users can hover over each label to view their definition. Scrolling further down, we see a card summary of scam type distribution. Clicking on the card, flip it over to reveal the definition of that scam type. Now let's move on to the post page, where users can explore scam-related posts collected from multiple sources. At the top, we showcase three key metrics, including the total number of posts across the platforms, the overall engagement count, including the number of likes, shares, and comments, and the sentiment breakdown, which is a visual percentage of positive, neutral, and negative comments received. Below the metrics, we have a scrollable list of posts organized into three sections by platform. The first section displays posts from the official website, followed by the posts from Twitter, and finally the posts from Facebook. On top, there is a filter section that user allows to sort posts by date. So you can get the oldest posts and the latest posts, and filter by scam type and scam framing, such as phone scam and game framing. There is also a search bar to search for posts containing specific keywords, like the phone keywords. To create a new post, we click on the Add button, and then we fill in the content field. Upon submission, the post is saved in a database and it appears in the post list. In the back end, a machine learning model runs automatically to classify for the scam type and scam framing. By clicking on the newly created post, we can view the result of the classified scam type and scam framing. For this post, the scam type is phishing scam and the scam framing is scam framing. So at the bottom, there's a related post section showing posts from the same agency that have the similar scam type and scam framing. So here are the related posts with the similar phishing scam and game framing. Now I will demonstrate logging in using a normal user account. Normal user cannot edit, create or delete posts. However, they can interact the post by liking the post or sharing it to their Facebook account. Once shared successfully, they can click on the button to redirect to the shared post. Besides, they can submit their comments. After submitting a comment, a sentiment analysis model runs in the backend to classify the comment as positive, negative, or neutral. Back to government agencies' account, the interactions are reflected in the engagement matrix, and the comments is shown. Moving on to the dashboard page, this page contains 4-step bar chart: the sentiment distribution by scan type, the sentiment distribution by scan framing, the engagement metric by scan type, and the engagement metric by scan framing. User can hover against each bar to view the details count, and the user can click on the Save button to save for the graph. In the account page, the social media sources connected to the agencies have been shown. Each card is clickable and will be redirected to the platform's official page. Now let's take a closer look into the intelligent component used in the system. The system performs text classification using logistic regression model. Where the new post is submitted by the government agency, the text is pre-processed and converted into numerical features using TF-IDF. The logistic regression model predicts the scan type and framing. The system retrieves the similar posts with the same predicted scan type and framing. Finally, the predicted labels and similar posts are displayed to the user. For the sentiment analyzer, after a user submits a comment, if the comment isn't in English, it is automatically detected and translated. The text is pre-processed. Non-comments are split into smaller parts to fit the model input size limit. Each chunk is passed through the pre-trained RoboDAR model to predict its sentiment. If there are multiple chunks, their predictions are combined to determine the final sentiment. The sentiment result is then displayed under the comment. With that being said, Scam Insight can help government agencies in analyze user engagement metrics and sentiment to measure reach of the post. It can help to tailor posts for each scam category and to identify which framing drive better audience response for the community. It can help to improve public understanding of diverse scam tactics, to equip individuals with knowledge and tools to recognize and report scams, and it can enhance trust in the digital platforms.